NFT minting engine, as I said earlier. So you'll be learning about React and Solidity. So actually, Solidity is a language that we use to build smart contracts. So we'll be learning about what is smart contracts, how to deploy them, how to build them, how they actually work, and everything. We'll be learning about that as well. And coming to next thing is there is something called ERC 721. So this is a standard from Ethereum that we use to build NFTs. So whatever the NFTs that you see, like the Bored Ape and everything, so all those things are ERC 721. Okay, so we'll be looking into that as well. And other than that, there's an exposure to industry standards as well. So we'll be looking into many industry standard production gear system, like how you can follow some coding guidelines, what are the standards to follow while building an application or planning to build an application. So all of those stuff, we'll definitely look into those things as well. And we'll also learn about blockchain as well. So we'll learn about blockchain, how it works, and why do you need to use blockchain, and then how blockchain is different from the existing centralized system as well. We'll look into those things as well. And we'll be working on Polygon PoS L2 chain. So L2 stands for layer 2. So we'll be working on Polygon. But this is actually something that even I'm not sure about even now, because right now there is just a second, guys. All right, guys. There was some chat message I just saw right now. All right, cool. So as I was saying, because right now the Polygon testnet has become terribly slow right now, so it's very hard to deploy the contracts. Even if we deploy the contracts, very hard to interact with it. It takes a lot of time, and we're not sure whether it was successful or not. So I'm thinking of either using Binance chain or Polygon chain. Not sure. We'll just try with Polygon first. If it fails, if it keeps on failing, if it's very slow, or if it takes a lot of time to complete the transaction, then we'll go with Binance chain. Okay. And also, other than that, everything remains the same. Like the building smart contracts, deploying it to the chains, everything will be the same. But only the part is that we'll test with Polygon first. If it fails, then we'll go with Binance. Okay. Other than that, we have Pinata Cloud. So you might be wondering how we can store the images, right? So we have these images in NFTs, right? So how we can store them, how we can decentralize them. So we'll be using IPFS for that. IPFS, in that, we'll be using Pinata Cloud as our IPFS provider. Okay. With that said, my name is Pawan, and I'm a co-founder at Duolearn. I'm a full stack developer and a blockchain developer at Nonceblocks. So you can follow me at my social handles here. And if you guys have any queries or doubts, we have our Discord community. So we have a Discord community here. So if you guys have any doubts or anything, we suggest you guys to come join in Discord community here, because WhatsApp and Telegram group when admins can message, right? You guys cannot interact with us. So if you guys want to interact with us or with me or Dave, or if you guys have any doubts, you want to clarify that, you can come here, drop your query in all our messages here. I'll share the link. Definitely, I'll share the link. Okay, so we have this channels here where you can share your queries. We'll definitely get back to you at that. We'll be always online here. Any doubts, we'll definitely solve it immediately. Okay, we'll try to solve it immediately, but if not, within an hour or two, we'll definitely help you out with that. Okay, we'll try to solve it in text first. If it does not get, if it's even more complicated, then we can connect via a voice chat here. We have voice chat somewhere around here. We can get into a voice chat. We can open up, we can share your screen. We can solve it. Okay, and also we have one of the initiative that we took, that is called Today I Learned. So whatever you learn today, let's say yesterday I did revisit some of my notes on blockchain. I did learn about gas fee and everything. So I posted some summary of that. So in the same way, some of the people here post some other summaries. We follow this as a regular practice, so that it creates a healthy learning environment as well. So if this sounds very interesting to you, I would definitely recommend you guys to join our Discord community, where we can have a regular interaction as a forum. So you can have this as a one-stop or dev support community, where you can get support from others. You can share whatever you learn. It will be really good to network as well. Okay. All right. With that said, let's just jump into some of the basics of blockchain. So since we shared the agenda, right? So today we'll be learning about blockchain and its fundamentals. Okay. Let me zoom in a bit. Okay, this should be fine. Yeah. Okay. So whenever I say blockchain, right, whenever we say blockchain, the first thing that comes to anybody, like anybody, the first thing that comes to your mind is this one, right? If I search for Bitcoin, so this is what it comes to your mind, right? Oops. This image. This is what it comes to your mind. Whenever I say blockchain or whenever you hear blockchain, this is the one that comes to your mind, right? So actually this is wrong. This is not blockchain, okay? It's Bitcoin. Okay, so what is blockchain? What are blockchain? Blockchain are essentially computers. Nothing fancy. It's just computers. Computers running some software. That's all. Okay, but there are some components that you have to understand that constitute or what that makes blockchain. Okay, those components are node, okay, node and blocks, node and blocks. So these combine to make the whole blockchain. Okay, so you can see computer A, computer B, computer C, and similarly we have certain computers here which are interlinked. So they have connections to one another, right? I'm not sharing my screen. I'm sharing my screen, right? Share screen. Can anyone confirm? Is my screen visible? Can anyone confirm? Is my yeah? Okay, so just check your pin, Sneha. So maybe you're pinned into my another avatar, so it might not be available. Okay. Okay. Right, coming back to here. So as we can see here, all these computers are interconnected, right? So we can see computer A has a connection to computer B, similarly computer B has connected to computer C. So all these have connection to one another. So it's like data available on computer A is available on computer B. Okay, so data is shared between them. So that's what blockchain is. Okay, blockchain is public. So first thing is it's public. It's decentralized. What is decentralized? So decentralized is nothing but nobody is under control of that. Okay, nobody controls that. Okay, it doesn't mean it's under nobody is controlling it, or it's not managed or something. It means that no single entity controls that. For example, let's say Ola or Uber, right? So you ride or you take up Ola cab, or you take up a ride or anything. So whatever the transaction you make on that Ola app or Uber app, so Ola or Uber controls that. They are the single entity who has control over it, right? If they wish, they can just delete you on the database, and for next day when you log in, it says you're not found. That's possible, right? But here it's not possible. Okay, so blockchain is not under one single entity control. Okay, it's decentralized, it's public, it is managed by a group of individuals. Okay, something called DAO. So group of people manage it. It's like for public. Okay, so here, let's see one of the base components that make the blockchain. The first thing is node. So node is nothing but individual computers here. Okay, so node is nothing but individual computers that running a blockchain software. And inside that node, we have a couple of things that's called blocks. Okay, blocks. So these blocks are something that hold all the records of your transaction. So let's say you send some money to me. Okay, so that's a transaction, right? I receive some money from you. That's a transaction. That transaction reference is held inside this block. Okay, in a form of hash. So it's held in a form of hash. The transaction is hashed. Okay, the reference for the transaction is hashed, and that is held inside this block. Okay, so with the transaction hash, you can actually see all the list of data, all the or what do you say, all the transaction details that occurred on that particular block. Okay, so this is the whole blockchain. Okay, in simple, this is all it is a blockchain. Blockchain. Okay, let me just let this guy in. Okay, blockchain in simple words, nothing but bunch of computers connected to each other. Okay, running a blockchain software. Okay, the software might be Ethereum or Bitcoin or Polygon or anything. Okay, it's nothing but bunch of computers running a blockchain software connected to each other in a decentralized manner, and which is not under a single entity control. Okay, nobody controls that. Okay, it is managed, not controlled, managed by individual group of people. Okay, and even you can become a blockchain node. You just have to run the software, and you should have like what do you say, enough hardware to support it, and you can become a blockchain node provider as well. All right, now coming to node. So what is a node? As I told you, node is a computer that holds the block. Okay, what is a block? Block is nothing but individual. A block is nothing but that holds the transaction records. Along with that, it holds many things like a target, nonce, and not nonce, targets, and other header information as well. But first, to keep it simple, just understand that block is nothing but a record of transaction, a group of transaction. Okay, so I have one more thing here. Here's the detailed view of a block. So here as I told you, we have a header. holds many information of the block and the transaction. Okay, so this is the whole structure of the block. So you have a transaction and header. Header has some information like target. I'll tell you what exactly target is. When I touch the topic of proof of work. So for now, header is nothing but some. It contains some header information. Remember in HTML we have head tag, right? That contains some information on the site. So that's what header does. Okay, header has some more information about the block. Okay. Coming to next up, how does this blockchain actually work? How does these new blocks are being created? As whenever we say blockchain, the whole we get this mental imaginary thing, right? Like this. This is what we get, right? So these are blocks and it's connected as a chain. I mean, that's exactly true. That's how these things are connected. Okay. But how does this new block get added here? How does this new block will be connected to the other blocks in the chain? How does a transaction that occurs on the blockchain will be added to will be added inside this block? How does this actually work? So the thing is, there is something called mining. Okay, there is something called mining. So how does this mining actually happen? So what is mining actually? Mining is nothing but creating a new blocks. Okay, so you saw blocks here, right? So creating new blocks is called mining. Okay, that's all. Okay, and people who do that is called miners. So I mean, people actually, humans won't do this. Like, people won't do this. They'll have a system that automatically does this for them, but we call them as miners. Okay, so miners actually are responsible for creating these blocks in the blockchain. Okay, so what happens is, so let's say you send some money to me. Okay, so that transaction will not immediately get added in the block. Okay, that will be in something called mempool. Okay, that will be in something called mempool, memory pool. Okay, so the miner has to bid to pick that up, that transaction up. So what they'll do is they'll solve a complex problem. Okay, they'll solve a complex problem to identify a hash. Okay, to identify a hash, that's called transaction hash. So what is this complex problem? So remember a word target that I mentioned earlier that will be inside this header. So the thing is, every block has a unique target. Okay, that target will be either a large, bigger amount, like a bigger number, depending on how many miners are available on the network. Let's say if there are many miners on the network available, then the target will be very low. Okay, it might be very low, less number. Let's say imagine a single digit, double digit number. Okay, if there are very low, less amount of miners on the network, then it will be huge number. The thing is, if the target is huge, okay, if the target is greater number, like let's say 3 digit or 4 digit, then the amount spent by the miner, right? The amount spent by the miner to calculate this transaction hash is less. Like, I mean, it will be less difficult. Okay, if the target is higher, the difficulty is less. Okay, if the target is less number, I mean lower, let's say around 2 digit or 3 digit, then this whole calculation takes a very huge amount of time. I mean, it will be very difficult for the miners to do it. So this is called proof of work. Okay, calculating this transaction hash is called proof of work. Okay, and the way they calculate is by determining a random integer called nonce. Okay, they have to determine something called nonce, and it should be in such a way that whenever they try to hash the transaction under nonce, it should result in transaction hash, right? Which should result in transaction hash, but it should always be lesser than the block hash. So there will be something called block hash. So when you compare block hash and transaction hash, the transaction hash should always be lesser. Okay, there are some values that we compare. Whenever you compare transaction hash and block hash, the resulting value should always be lesser than the block hash. So in that way, you have to determine the nonce, and that way, that's what takes a lot of time for the miners and a lot of computation resources by the miners to solve this one. This is what proof of work in very high level. Okay, this is why it takes a lot of computation power for the miners, and once they successfully do this, they'll be rewarded. Okay, they'll be rewarded with some Ethereum if they're doing on Ethereum, or they'll be rewarded some BTC if they're doing on Bitcoin network. But the thing is, this is how the blockchain is secure. Okay, because the miners know that this takes a lot of their time, this one takes a lot of their resources, but even though they participate in this, okay, with their full passion, like they'll be like, okay, I'm really interested to solve this one. Okay, and they'll solve it and they'll get rewarded for that. And if they get rewarded for that and they successfully give us a transaction hash, it means the blockchain is working fine. right? If you get a valid transaction hash, then the blockchain works fine, right? If the blockchain is working fine, then the many people are happy. People who are working on that, people who have applications on that, they'll be happy. So the whole blockchain management will be perfect. Okay, so this is how the actual transaction happens on the blockchain. So let's say you send a transaction here. So let's say we have person A sending a transaction B. It won't immediately go to blockchain, but it goes to mempool here, and the miner picks that up, and they try to perform proof of work. And if it is successful, then it goes inside the block. Okay, and for the whole process, you will have to pay gas fee. For the whole process, you have to pay gas fee, and in that gas fee, some of the amount will go to miner, and miner will also the network. Let's say you are working on Ethereum chain. Ethereum chain will also reward the miner. So the miner gets some part of your gas fee, also some of the Ethereum for him. So that's how this whole blockchain actually work in simple manner. Okay, there are many technical details here, like how the hash exactly happens, how they calculate, how the gas is actually estimated and everything. But let's not go very deep into this because it's really confusing at the beginning stage. But we can have, like maybe we can create another session where we go in depth on this blockchain. We can learn about the gas and everything very in depth. Okay, so we have one more topic left, that is gas. Let me tell you what is gas. Before that, you guys have any questions? If any doubts, just drop it in the chat right now. Is a block created every minute in blockchain? I'll address that. That's a very good question. I'll just keep it here. Okay, I'll address that next. Any other question, guys? I just want to make sure you guys are catching up here. There's no more question before I move to gas, because this is very important topic on blockchain. What is nonce? That's a good question as well. So nonce is nothing but a number, a unique number. That's it. A unique number on the block. That's a simple number. Okay. Okay. Coming to is new block created for every minute in blockchain? Actually, it is created every second. Not every second though, for a couple of seconds. So there are like the legendary chains, the Bitcoin, the Ethereum chains and everything. These chains actually take a lot of time. I think Ethereum is around 15 minutes. Ethereum gets a new block for every 15 minutes, I guess. I'm not really sure about that number. But we're working on this in our company. We're working on this chain that's called Elysium chain. So actually, the chain that we are working on creates a new block for every 6 seconds. So for every 6 seconds, a new block is created. Even though the block has no transactions, since it's on development, there won't be any transaction inside the blocks. But it says even though it has empty transaction, we create new block for every 6 seconds. How much time taken to add a transaction to block? That depends on the chain. Depends on the chain, and then as I told you, the amount of the the level of difficulty of the proof of work problem. So depending on that, it takes some time for the transaction to add a block. And yeah, does each block define gas fee and value of the blockchain? Yes. Each block, each of these blocks in the header, right? In the header, each of these blocks has a base gas fee. Base fee. So depending on this, we calculate the whole gas fee. Okay, is each chain, I guess, takes 15-30 seconds. No, it won't take seconds. I think it might take a lot more time than seconds. If you're talking about Ethereum. Where is mempool present? What is the main purpose of mempool? Explain please again. As I told you, like whenever you try to make a transaction, right? Let's say A is sending some money to B on crypto, like the blockchain network. So it is first stored on memory pool. So memory pool is nothing but like you have this memory in your system, right, where you store all the information of the current executing task and everything, right? Same way. Okay, this memory pool of the miner that will be stored over there. Every transaction, no. It actually is different. Some blockchains create new block for every transaction. Like let's say I send some tokens to someone on blockchain. That's one of my transaction. I get a new block. But some blockchain group some amount of transactions to a single block. It depends on chain. How does it benefit the network by creating block in 6 seconds? I mean, that's their rule, because it depends on the use case as well. So if you're building for games and everything, it should create blocks very soon. that there won't be you won't be in a queue of the transactions, so that you can be minting the transaction as soon as possible. Okay, so let me jump into the gas right now. So here, what exactly is gas? So remember, whenever you're doing some online transaction, you tend to pay the transaction fee, right? Let's say you're sending some money to some people, you tend to pay some fee for that, right? So that's what is that? That's a transaction fee. Similarly, in blockchain, whenever you try to do a transaction, you have to pay some fee. That is gas fee. So what is gas fee? So remember, I told you, like, nobody is in central control of the chain, right? So the chain has to be managed. So if it is going to be managed, then it has some, like, it has to be like funded, right? It has to be funded so that they can take care of some things. Like, let's say Ethereum has some of its developers working on it. So how can Ethereum developers get paid if it's not being funded? That's why we use gas. So what happens gas is, so I mean, not only funding the chain, but also there are some more stuff. I'll explain that to you one by one right now. So let's say I, okay, so I send some money to A to B, A sends some money to B. So A has to pay some gas fee here. So what happens here is, whenever you pay gas fee, some amount of that gas fee will be sent to miner. Okay, some amount of that gas will be sent to miner. Let me just make this clear. Okay, and some amount of that will be burned. What is burned? I mean, it will be BURNED, burned. This is actually done to keep the coin stable. Let's say, we have this Bitcoin, that is BTC, and Ethereum, that is ETH, right? In Polygon, we call it as Matic. So these coins have some value attached to them, right? Let's say Bitcoin is around 20 lakhs, I guess, current price. Ethereum is around 2 lakh or something. Matic is around 70 something. So these are the price of these coin, right? So this has to be kept stable, right? And they should not keep on going down and everything. So we burn some of the cash so that it is, if you burn here, then it means that the total supply will increase. Meaning, so let's say we have around 1,000 Bitcoin right now, total supply. Around 800 Bitcoin are already sold. So 800 people already hold Bitcoin right now. So remaining is 200. So if you keep burning the Bitcoins here, then this 200 will keep on increasing. Let's say I burn one Bitcoin here, it will become 201. 201 Bitcoins are available for sale right now. So like way, it keeps creating a demand instead of, totally running out of stock, something like that. Okay, I hope that made clear. Okay, and next thing is gas only this much? Like, only paying to miner and then burning the token, is that's all we use gas? No. To understand more gas in depth, you guys have to understand how the whole new meaning of smart contracts. So I remember I told you smart contracts before. We'll be looking into how to build and develop smart contracts later, but you guys have to understand what exactly is smart contract right now so that you can understand gas better. Okay, so here, let's say I deploy my application on blockchain. Okay, it is decentralized, right? You cannot once you add data in your blockchain, you cannot update it, right? Once you add some data in your blockchain, you cannot update or delete or do anything with it, right? But how is it secure? How is it safe? How is it trustworthy? That's what smart contracts comes here. That's why we use smart contracts here. So what happens is, as a name says, smart contract. So you define some instructions inside smart contract. Okay, you define, let's say, send money to A, receive money from B, send the same money to C. These are the instructions, right? And once you deploy the smart contract to the network, to the chain, it will do the same task no matter what. Okay, you won't be able to update it or delete it or modify the instructions or whatsoever. Okay, it does not really, listen to anyone else. It does not respond to any manipulation or malicious task or anything. Whenever you send a request, it checks if the request is compatible with this instruction. If it is, it tries to execute it, or else it rejects it. That's all. That's how it's trustworthy, because you first define the contract here, you verify whether all the steps is right or wrong, and then you deploy it, and that's it. Okay, it cannot be broken, it cannot be it cannot malfunction or anything, so it is trustworthy. So for now, that's enough about smart contract, because we'll be looking into it deeper eventually in the workshop. But how will it like relate to gas here? So as I told you, since smart contract is nothing but normal code that we write, we use Solidity language for that, right? And since Solidity is a programming language, remember, in programming language, we have this logic building, right? We have arrays, we have loops and everything, right? So what if I write a while loop inside my smart contract and I make it infinity loop? Let's say I say while true, do something. So if I say while true, then this is an infinity loop, right? It keeps on running, right? It won't stop because while is true here. And I just create, I keep on creating some other, what do you say? I'll keep on doing some malicious task here so that it will keep on running. Once this function is invoked, it won't stop. So I deploy the smart contract on the blockchain here. Now I make a request here, right? Now I make a request. So do you think this will keep on running and it won't stop ever again? Is that the case? No, blockchain doesn't allow this. This is how blockchain is pretty secure. This is how blockchain is pretty smart here. Why is that? You send, whenever you send a transaction to chain, right? You have to send a gas fee along with it, right? Now what happens is, since whenever you run your smart contract, you have to use a computation resources, right? You have to use the memory, you have to use processor and everything, right? So the blockchain will use your gas as the fee for those computation resources. Okay, so let's say you are keep on you have paid around let's say around let's say 1,000 rupees as gas. You won't be paying 1,000 rupees. I'm just getting this as an example. Okay, let's say you send 1,000 rupees as gas. Of course, you won't be paying in rupees as well. This is purely an example. Okay, so you'll be sending 1,000 rupees as gas, and you run a while loop here, the infinity loop. So blockchain, for every iteration, blockchain will be deducting some amount. Let's say blockchain keeps deducting 10 rupees for every iteration. Once the loop completes, 10 rupees is deducted. Again, 10 rupees. So it keeps on deducting it until runs out of the gas. So 1,000 rupees is over, it is stopped. It is aborted. Directly, it is directly cut down from the process. So the process is killed. So your while loop will be stopped. So what happens here is blockchain will be secure here. So since it directly cut down your processor here, blockchain will be secure since it's not running the while loop anymore. But you lost 1,000 rupees, right? Here, the sender lost 1,000 rupees because it didn't return anything. The transaction failed. Since they run out of gas, the transaction will fail. It says you run out of gas. Okay, but the blockchain was secure. Blockchain didn't get affect anything, but you lost the 1,000 rupees. I mean, you lost your gas fee. So that's how secure is blockchain. So gas fee not only rewards miner, not only helps keep the coin stable, it also helps the chain to be secure. Okay, by letting you paying for computational fee. Okay, this enables them to provide you some more computation and more nodes as well. Okay, so where is this computation coming from? It's called EVM, Ethereum Virtual Machine. Okay, similar to, as I told you, right? Blockchain nothing but computers. So that's what EVM is. It's nothing but a virtual machine or computer where you have processor, memory, and everything. Okay, so this is about a little bit of gas. So while building the contract and everything, you'll see how the gas is being deducted. What is the main gas fee? What is the base gas fee? What is the priority gas fee? Right, you'll be seeing all of those stuff throughout this workshop. Okay, so to give an example, I'm going to show you a simple transaction that we made on Polygon. I'm going to show you a mainnet transaction itself. Okay, before that, I forgot to explain one more thing. There are two types of chain. No, three. I think there are three, but we barely use three, but the standard is two. The standard is two. The first thing is mainnet. The second one is testnet. Okay, the mainnet and testnet. So as the name suggests, the mainnet is where the main transaction, like the production transaction happens, the real transaction happens with the money going around and everything. Testnet, as the name suggests, for testing development purposes. Okay, so first let's see, let's go to Polygon chain. Let's explore Polygon chain and let's see the transaction happening on mainnet. Okay, I'm going to search for Polygon scan. Right, Polygon scan. So this is the official Polygon chain explorer. So this is the explorer. So where you can, if you have the transaction hash and everything, you can actually see the list of all the details of the transaction. So let's see as you can see here, blocks are being added. Like you can see, new blocks are being added for every transaction. There are 98 transactions here. There are 61 transactions here. There are 88 transactions here. Right. So these are the latest blocks being minted at live, at present, at real time on Polygon. So here there are latest transactions happen. So let's just inspect this transaction. So this was a transaction that happened right now. So this is the transaction hash. As you can see, it is a lot of number. This is how this was generated by proof of work. Okay. And you can see this is the block number that was added. This was transaction was added to this block number. I mean, it was grouped under a bunch of transaction and was added to this block. Okay, the status is success. So the transaction was success, the timestamp, and from. So this is the address. Okay, this is the address from whom the transaction was made. This can be either a smart contract or can be a user account address. Okay, and interacted to. Okay, to. This is a contract address. You can see it says contract. So this was the account. I mean, this was a user account, wallet address, and this was the contract address. So address is nothing but a unique identifier. You have your phone number and everything, right? That identifies you. Right? Whenever I dial your number, it directly goes to you, right? That means that phone number belongs to you. Similarly, this is a unique identifier. It can, if it's a wallet address, then it belongs to the user. If it's a contract address, it belongs to a smart contract. Okay. And you can see transaction action. So there was some action that happened. It was some swap action from WE to USDT on QuickSwap. And there was some token transferred here. So you can see these are all the transaction details. So with only this hash, we are able to uncover many of these details. So you can see there were some three major things happened here. There were 3 transactions made. You can see from two, and some of the tokens were transferred here, right? And the transaction fee, here is the gas fee. So this is how much the gas fee was spent. So in US dollars, it's around $0.01. Matic is the official currency of Polygon. Remember, in Bitcoin, it is BTC, right? In Ethereum, it is ETH. So in Polygon, it is Matic. So they spent around 0.008 Matic for this whole gas fee to make sure this swap happens properly. Okay. And the gas limit was 3 million. I think it's 3 million. Yeah, yes. Okay. Or in Indian, it's 3 lakh. Okay. So this was the gas limit. So what is gas limit here? Remember this example I gave you, this 1,000 rupees as example. So this 1,000 here is the gas limit. Okay. So let's say you have a valid transaction here, not the infinity loop, just a valid proper transaction. So you send 1,000 as the gas limit, but you end up paying only 50 as the gas fee. So the remaining 950 will be refunded to your account. Okay. So that's how it happens. And you can see the gas used by the transaction was only 72%, that is 240. So the remaining will be refunded to this wallet account, this account. Okay. So other than that, you can see some of the fees were burnt. So some of the Matic among this was burnt to keep the Matic stable. And other than this is the base gas fee of this block, this 3-to-1 block. This is the base gas fee. Where is that? Here. This is the base and this is the gas price. At present, this is the gas price. So how can you find the gas price of a particular chain? You can just go to and check there. So for now, for Polygon, we go to polygonscan.com/gas tracker and we get this current fee. So currently, standard fee is around 33 GUA, and for fast it's 52 GUA, and then for rapid it's 53 GUA. So this is how much you have to pay. And these GUA, way, and everything are nothing but units. So remember, in India we have paisa, right? The main is rupees, and the next unit is paisa, right? Similarly, in Ethereum, the main unit is Ether, and the next is GUA, and next is way. So if you go to ETH converter, so you can see here. Okay, the least unit is the way, and the next comes GUA, and next comes Ether. So for 1 Ether, you can see we have GUA and the way value. It's similar to like paisa and everything, paisa and quarter and everything. So 1 rupee, paisa and quarter, something like that. Okay. Right. Other than this, you can also see the input details, but it's actually encoded, so you won't be able to see that. So yeah, that's it. So this is how we can actually explore the whole transaction with just a transaction hash or the contract address and everything. Okay. So in the following days, when we start writing our Solidity smart contract, we'll also deploy a contract here. We'll also come back here. We'll try to debug whether the transaction happens properly or not. So if I mint an NFT, right, I have to see here that NFT has been transferred here. The from address should be mine, the to address should be the contract, and it should be the NFT ID. Okay, we have to see all these stuff here. Okay, so yeah, so this is how the transaction actually looks like. I mean, it's not like this is the way the transaction is structured in the block or not. It's not like that. In the block, it will be like a raw format. Polygon people actually they get the raw format, they process it, and then show it to you in a very interactive way. Okay. All right, guys. So this is all I have planned for today. We'll go to some fundamentals of blockchain. Okay. Let me just read the comment once. Can we run a node through cloud? You can actually, but you have to keep an eye on the billing. Okay, because blocks keep on generating, that keeps on eating up your resources. So you have to keep an eye on the billing. Blockchain is storing the transaction data, right? Where is the data? Where does the database resides? There is no database or anything. So remember that I told you EVM. So EVM stores your data. Okay, the transaction is the reference for that. In India, being a blockchain developer is worth it. It is definitely worth it. It is worth it, 100%. How to resolve bug in smart contract which is already deployed on mainnet? Oh, if you deployed on mainnet, you have a bug, that's pretty bad. So you have to test it thoroughly on testnet first. Okay, so you cannot update it. Once it's deployed, that's it. It's final. You cannot do anything. Okay, so let's say you deploy a smart contract and you find a typo in your smart contract. That's it. It's done. You cannot change the deployment. You have to deploy a new one. Okay, so that's why we have testnet here. Okay, make sure that the testnet, your application is working fine on testnet. Only then go to mainnet. What is your chain name and how is it special or different from Bitcoin? My chain name? I didn't get you. I didn't actually get you what you mean by my chain name though. If you can give me some more context on that, that's fine. Okay. So as I was saying, guys, so we did touch into some fundamentals of blockchain, but this is not it. We have many things planned, but doing that all in one day would be really overwhelming. So we'll keep it, for the rest of the bootcamp as well. So once we touch the smart contract development, we'll learn about creating, learn more about smart contracts, deploying smart contracts, the gas, the way it's actually interact, how to interact with it, and everything. Okay. You mentioned your company is creating a blockchain, right? No, my company is not creating. I mean, we are working for a client who's actually wanted a new chain. So that's actually very game focused. The metaverse game focused. So it's not like we are optimizing it for many dApps that are being applications building on, Polygon is actually built for supporting dApps. So there are many decentralized application on blockchain, but the chain that we're building is focused on games. So it is optimized and pretty, built, architected in a way to support all these metaverse games. Okay. All right, guys. Let me stop sharing my screen and enable mic so that if you guys want to talk, you can talk as well. All right. So the mic is enabled. So if you guys want to talk with me, you can talk. Don't turn on your mic and talk to me, or else chat is also fine. Oh, you mentioned, okay, hard hat versus tougher, which is best? Both are best. They have their own set of features as well. We personally use hard hat. Even in here, we'll be using hard hat, but truffle is also fine. You can use either one of them. That's fine. Guys, I'll be okay. Roadmap to get a job as a blockchain dev. There is no certain a fixed roadmap or something. It all starts with the basic development skill, the Web2 skill basically. So you should be familiar with either React or any backend language where you can use blockchain. Okay, and then you can jump into directly working with smart contracts, and from that you can directly jump into how blockchain works and what happens internally, the cryptographic hashes and everything. You can learn from that. So first start with some language where you can develop some applications and then jump into the blockchain. Will you do design patterns, solid principle to become expert solid developer? I think no, but it is really good if you have one, because smart contracts are prone to many hacks, not hacks, but many logical errors, right? it's good to have some of the design patterns, actually design patterns, to be to be precise. It's good to actually have it. What are the prerequisites for learning blockchain development? As I told you, you should have some if you just want to become a contract developer, Solidity developer, then that's fine. You can directly jump into Solidity language. But if you want to become a full stack blockchain developer, then it's good to have some knowledge on full stack development as well, either React or Node.js, and then jump into blockchain development. We're going to do a project based on Ethereum or Polygon. We'll be doing on Polygon, but since Polygon is L2 chain, it's actually derived from Ethereum chain. HTML Python is required for blockchain. I think Python should be required. In HTML, I guess with React, it's fine though. Is workshop going to do? Yeah, that was answered. In smart contracts, uh, it's not like we use design pattern for every single contract, right? So when you're building a very big contract, let's say that has a lot of complex features, then design patterns might help you out with that, but it's not compulsory that you will be using design patterns over there. But there are some things that you have to take care, like adding a withdraw function, which is really, really important because you'll be locking out tokens inside your contract. If you don't have a withdraw function, then it will be locked there forever. So like adding withdraw functions over there, and then adding re-entrancy guard. And there are some many attacks that are common on smart contracts. So you have to make sure that you have guard for every single thing, and adding modifiers so that only owners or only admins can access some things. These are important. Okay. And so on. Yes, in this. Yeah, we'll be working on ERC 721 soon. When we reach the smart contract session, we'll be doing that. I'm familiar with Solidity, but my issue is multiple logic. I mean, you have to practice a lot because logic is really important on smart contracts. If you think you're not confident enough, just please try to practice. It's really important because if it's normal API or something, you can edit it, right? You can update later, but smart contract is not like that. If you deploy once, it's final. So you have to make sure that you have your logics fine. You have your logic building skill up and running. Okay. What is the what is the use for Open Zeppelin? I think Open Zeppelin is a community, right? I mean, Open Zeppelin are amazing people. They give you many utility contracts. So it's like they have many contracts defined, and then it's like a standard thing. It's a standard for secure blockchain application. Yeah. So I think they also help you with many contract audits as well. So if you have some contract you need to be audited, so they have some experts. You can send it to them. So these people will audit your contract and check whether it's proper, it compatible with the standard, or it has some loopholes or anything. And these guys also propose many contracts as well. Like, the ERC 721 and everything, we'll be using Open Zeppelin standard here. Whenever we build, even in this workshop, to build the contracts, we'll be using Open Zeppelin standards. Video recording of this lecture. Yeah, I'll be sharing the recording of this workshop. It might take some time though, because when I stop this recording, it takes some time to get processed and then send it to our email. Google Meet takes some time. So I'll just share it. Okay. For beginners to learn blockchain, what are the basic? If you're just looking for just Solidity contract development, then go with Solidity. If you're looking for the whole application part and everything, learn about the application for building with React or building a backend with Node.js, and then go with the smart contract development. Okay. Is smart contract auditing similar to QA? Kinda. Yeah, it is. It is though. But I mean, yeah, we'll be testing and we'll be creating reports and everything. Yeah, it is kind of similar to QA. QA and blockchain though. You can think about something like that. Okay. Yeah. Any more questions, guys? We have another 10 minutes to kill. So, I mean, you can turn on your mic and talk, right? Instead of just putting a chat, that would be better. We can interact as well. Come on, guys, turn on your mic and, talk to me though. That's fine.
Pavan, I have.
Yeah.
Yeah, the thing is, currently, if I look for a Solidity or blockchain
Mhm.
developer role, like they are asking, at least 2 years in Solidity and at least 5 years in a backend developer role. The
Hmm.
current scenario I'm saying. So it is bit difficult without having a Node.js or Golang experience. So I am facing right now. But in other countries there are more opportunities, more salaries. But in India the opportunities are also less. Is what I feel.
No, first thing is do not compare the salaries with other countries because the economy is different from other countries, right? From India to other countries. So next thing is, as you said, that people are asking for the languages. The reason they ask you for languages because writing scripts. So you should be able to write scripts. Or let's say here we build with Node.js, okay, TypeScript. So what we do is the blockchain devs not only write Solidity smart contracts, but they also write test cases in TypeScript. Okay, they have to write test cases. They have to make sure that the contract adheres all the test cases, and the test cases covers the entire smart contract code. Okay, so only for that reason they ask you for the code, and also we write some scripts that enables you to like automate all the let's say you are doing some staking, right? You have some couple of addresses, you have to send the staking to them. So in that case, you have to know some language, write the script, and run that blockchain. I mean, run that script. That script will essentially run the call the blockchain method and do the task for you. So for
Mm.
these reasons, you need some language, either Go, Python, Ruby. I mean, not Ruby though, Rust or JavaScript or anything. You need some language. And the experience part, do not worry about the experience part. Just worry about the concepts part. You need to. There are some certain contracts that you need to be familiar with if you're going to blockchain, like ERC 721, 20, ERC 20. Basically, the open supply standards. Just go to open supply, open their contracts panel, and then they have list of standards over there. Just learn about them. Okay, and then
Mm.
you have some things like bridging. There are some things on blockchain called bridge applications. You have to know about them. There is swap. You have to know about them. Okay, and there is governance. You have heard about DAO, right? Essentially, these
Yeah.
DAOs are like governance contract. Okay, you have to know about this one as well. Okay, and then there are things like there are some more things, but you're getting a basic idea, right? So if you know on about these contracts, and if you have some projects to showcase on this project on these contracts, you don't have to worry about the experience part. You'll get hired. Okay.
Okay. Regarding decentralized finance, it's booming,
DeFi, yeah.
right?
Yeah, it's actually very interesting though, but there are some loopholes in that as well that we have to be careful about. But DeFi is also amazing tech.
Is it like in 15, 20 years, banking sectors will become a DeFi?
I'm really speculating that as well because it's pretty hard to change every single people, right? It's
Maybe
not. I
15,
mean,
20 years, I'm saying.
yeah, even
20
though
years.
even though 50, 20 years, it's not like every single person will be turned to like using DeFi tech and everything. But I'm not saying it's not impossible, but it is possible though. But banking sectors won't be quiet, man. Right? They won't be quiet in this. They will do something and make sure that they won't be eradicated. That's for sure. I mean, look
When
at it.
internet
Bank,
came, uh, when
yeah, go ahead.
internet came, banking sector had the same thing. Now every bank has internet. Nothing is working without internet, right? So same
That's one of
thing
the
could
thing. And
happen.
also you have to think about one thing. This bank provide loans for many people, and many business people take thousands of crores of loans from these banks, right? And there is no
Yeah.
record of these crores. I mean, if you want to check what happens to these thousands of crores that someone took, there's no record. I mean, recently Athana took around 1,000 crores or something with SPR, right? Is there any record available for public to watch on that? No. But if he takes 1,000 crores of some, let's say Ethereum on each chain, every single record is available over there. Whatever he spends, it's available over there. So these guys they won't like to show off all their transaction list for the public. So they won't actually encourage DeFi. So even if DeFi is coming up, even if DeFi is trying to eradicate banks, they are going to be someone or some organization that's going to kick them out. Even India government did the same thing. India government put heavy hefty taxes. They tried to ban every single blockchain company. So there is no blockchain tech in India right now. Right. Can we see a DeFi company running in India? No. Can you see an NFT company running in India? No. We have Coin-T6 and everything, but even that's relocated to Dubai right now. So it's pretty hard right now. I mean, I don't think bank it will be completely eradicated, but it will be like 50-50. DeFi will grow. It will reach many huge number of user base. It will create a very big, revolutionize the whole banking sector, but it won't eradicate the existing banking sector. That's for sure. Polygon is
Okay.
from India, but it is in Dubai right now. The headquarters is in Dubai. Okay, it was from Indian founder though. It is not being operated from India right now. I mean, if your headquarters is in India, then you have to pay FP taxes. But they have their headquarters in Dubai, so it's like right now it's like a Dubai-based company, though. Okay. Right. Any more questions, guys?
Hello, sir.
Yeah.
Sir, what will you suggest to learn about the Web3 tech stack?
What did I suggest to learn about Web3?
Tech stack. I mean the languages, Solidity, and the different frameworks.
Oh, for that, in Web3, you can learn Rust as well, because in Solana we write the contracts in Rust. First, just learn about Solidity first, because Solidity is used in many other chains. Because whatever the chain that's EVM compatible, you can use Solidity contracts over there. So when you learn when you learn Solidity, your reach is pretty huge, so that you can target many other chains as well. And then you can jump into some other languages as well, like Ink or Rust or anything, something like that. Okay. Is crypto legal or not in India? It's not like illegal, but you will have to pay hefty taxes on that. Uh, I think I read NFTs about NFTs legalization a couple of days back. It seems like you cannot trade or buy or sell NFTs in India. I'm not sure if you can mine NFT in India, because even I had the plan, like we'll try to provide a leaderboard for you guys for this whole workshop. And if you guys top the leaderboard, top 3 people will get some NFTs. That's what I planned initially. But then I started Googling whether what is the compliance issue for NFTs if you mine NFT or mint NFT in India. And I found out that there was no information regarding that. Information was like not pretty good. So I thought, let's just drop this. Let's not get into some legal issues or anything. So I don't think you can mint or trade or buy or sell NFTs in India. I'm not sure about it. You guys have to do some R&D on that though. Okay. Yeah, you can get some job as a fresher on blockchain, but please keep in mind, since blockchain people, if you are hiring for blockchain role, it means that the job going to be pretty it's not like you'll get some time to build or time to learn or something like that. You have to directly jump, write code, push it, and get verified. Write code, push it. It should be something. It will be like a fast pace. So before getting into a fresher role, try to have some more, exposure on blockchain tech. As I told you earlier, try to go with open supply contracts. Try to learn about DAO contracts. Try to learn about bridge, swap, all these contracts before getting a job as a fresher. Okay, they will also increase your CTC as well as your reputation in the job as well. Roadmap for blockchain dev. I don't have pretty good roadmap though, but you can learn from this. Learn Web3. Learn Web3 DAO actually. These guys have pretty good structured courses. Okay. Right.
Can I say like React, Solidity, and Hard Hat, Ether.js, Open Zeppelin? More than enough.
I mean, these things are like tools you use to build the application, but you need to know about the base fundamentals as well, right? So it's best to know, like if you're targeting for Solidity developer, then you need to have all these knowledges, like Ethereum standard contracts, and then this governance contracts and all those bridge contracts, swap contracts, and everything. So it's good to have at least a simple projects built on top of these contracts. Okay, because the recruiter will definitely ask you this.
Okay.
Right, project recommendation for resume as fresher. I'm not really good at recommending projects, guys, to be honest. You might have to Google that. I'm not really good at recommending projects. All right. Anything else, guys?
Sir, should I take online paid courses to learn some Solidity?
No. Just try to learn Web3 DAO for blockchain fundamentals, and for Solidity Smart Contract, you can go with this Crypto Zombies. Go for Crypto Zombies. You can learn smart contract building Solidity smart contracts with a gamified platform. Okay. And learn Web3 DAO will teach you all the basics and fundamentals you need about blockchain, like gas fee, mining, proof of work, and everything. Okay.
Means internet has enough resources.
Yeah, exactly. That's true. I was a part of. Can I mention that I was a part of? I didn't get to like. What do you mean by the part of a blockchain developer? I didn't get you that. Can you give me some more information, Taro?
Hello, sir.
Yeah.
Sir, internet available, so there are many other roadmaps for a blockchain developer. They have been updated in the internet. As a basic and beginner, can we follow that roadmap?
You can though, yeah, but make sure that you, because there is roadmap curated to different types of people. Because some people come from very back-end only road, like back-end only career path. Some people come from only front-end only career path, right? Some things are curated to those people. So just verify whether it's right for you or not, and then try to proceed with that. Okay.
If that happens, what we need to take about, sir?
No, just think about like what exactly you want to learn as well. Because as I told you, with Solidity, you need to know a language as well, right? So think like which language you're interested in. So and also think like whether you want to become a full stack developer, full stack blockchain dev, like people who build applications as well as contracts, or just the contracts. Okay, in that way, proceed with the roadmap. Okay. Is front end compulsory to learn? It's up to you, Prasad. If you want to build applications along with blockchain apps, then yeah, you need front end as well. Okay.
There is less resources for learning, sir. Would you recommend any other learning platform?
Actually, I recommend you to go with Learn Web3 DAO because that teaches you the fundamentals of blockchain. I mean, whatever that you need on the blockchain part, and Crypto Zombies for the Solidity part. So this covers you the blockchain developer part, and the rest is up to you. So you can choose whichever way you want, like become a React dev or a full stack developer, or the Golang developer or anything. Learn Web3 DAO and then Crypto Zombies will give you everything that you need on the blockchain side.
Yes, sir. I might reading that IIT Kanpur is suggesting a blockchain full stack blockchain course. Can we interested? We take that.
You mean from Simple Learn or Great Learning from those people?
Yes, yes.
Don't you think that's pretty expensive? Their courses are pretty expensive. And whatever they teach you, actually, they learn Web3 that will teach you for free, to be honest. Just try to give
Yes,
it a
sir.
try.
That's expensive.
Learn Web3 Dava
Yes.
has these 4 tracks, beginner, junior, sophomore, and senior. So if you complete all those 3 tracks, then you will be amazing developer. Okay, it's more than like, I don't know. I've seen this from Great Learning or Simply Learn. I don't know, but it was more than 1 lakh, I guess, for blockchain dev. The fee was more than 1 lakh. It's pretty expensive.
Yes, sir. I'm just a basic beginner. I started to do, so I have a confirmation.
Yeah, don't go with paid right now. Just try Web3 DAO once. If you don't find it good, then maybe you can look into alternative. Okay.
Okay, sir.
Yeah, great. Okay, why Golang is recommended for Hyperledger, Golang better than Solidity? I think Hyperledger is not EVM compatible. That's why. Because Solidity is only work on EVM compatible chains, not on other chains. So that's why Golang might be recommended for Hyperledger. Okay. All right, guys. So it's 8:04. So let's wrap up here. So let's meet tomorrow. Attendance. Oh yeah. Thank you so much, guys. So I have enabled the attendance tracking here. So I'll get all the list of attendees here. So people who attended and everything. So next thing is the recording. I'll be sharing it. It takes some time though because we have to receive it from the Google Meet. So it takes some time to receive it. Even after receiving, it keeps on. It will be under processing. So it might take some time for you guys to view as well. So better to download and watch it from Google Drive. Okay. So with that said, thank you all for attending, guys. It was amazing meeting you all. So from tomorrow,